All right, welcome back. Here we are at the finish line of our deep dive into Introduction to Statistical Learning. And we're saving one of the most exciting topics for last, unsupervised learning. This is where we get to be data detectives, uncovering the hidden patterns and the secret stories that your data has been dying to tell you. So let's jump right in. So let's start with the core challenge, right? Imagine you're sitting on a mountain of data. It could be user clicks, medical charts, financial transactions, whatever. But there's one giant thing missing: labels. There's no good or bad, no category A or category B. It's just raw, unlabeled data. I mean, really think about it for a second. How does Netflix just know you're going to love that quirky documentary? Or how can your bank flag a weird-looking transaction in milliseconds? It's not like they have a pre-labeled list for every single person and every possible purchase. No way. They have to discover these patterns from scratch, in the wild. And the how is exactly what we're about to get into. And that right there brings us to our main idea. Unsupervised learning is basically the art of letting the data speak for itself. It's all about finding those natural groups and hidden structures without us telling it what to look for ahead of time. So let's look at our first major tool for making this happen. First up is principal component analysis, or just PCA. Now, if your dataset is like a super long, really complicated novel with hundreds of characters and subplots, think of PCA as the tool that writes the perfect one-page summary. It's all about cutting through the noise to find the main plot. So here's the core concept. PCA takes all your variables, and we're talking maybe dozens or even hundreds of them, and it cleverly mashes them together into just a few brand new variables. We call these principal components. And these new components are specifically designed to grab the most important information, or what we call variance, from the original data. You can think of variance as the action, the drama, the diversity in your data. PCA finds the directions with the most action, which lets us boil down a massive spreadsheet into its most critical trends. This is a game changer for visualizing complex data and can even make our other models work better. Now, this might sound super complicated, but check this out. This is what's so cool. This single line of R code is literally all it takes to run a PCA. The really important part here is scale equals true, and we'll circle back to that in a bit, but just appreciate how accessible this incredibly powerful technique actually is. And voila! This is the payoff. This is a perfect example of PCA's magic. That one little line of code transforms a clunky table of crime stats into this beautiful, simple 2D map. All of a sudden, you can literally see which states are similar to each other just by how close they are on the plot. It's a huge simplification that just instantly reveals the underlying structure. Okay, let's build on that and move to our second big tool. If PCA is all about summarizing the story, then clustering is about finding the different groups of characters within that story. This is the technique that automatically finds the natural tribes or communities hiding in your data. Now, clustering really comes in two main flavors that you gotta know. First, there's k-means. With k-means, you, the data scientist, have to make a big decision right at the start. You have to tell the algorithm, hey, I want you to find exactly 3 groups, or 5, or whatever your k is. Hierarchical clustering, on the other hand, is totally different. It doesn't ask you for a number. Instead, it just builds this beautiful tree from the ground up, showing you how the data wants to group together, all on its own. And you guessed it, just like with PCA, the code to get started is super direct. This one command here runs what's called a complete linkage hierarchical clustering on that same US arrests data. We're just telling R to figure out the distances between all the points and then build that tree structure for us. And this is what it gives you, this fantastic visual called a dendrogram. Honestly, just think of it as a family tree for your data. Way down at the bottom, every state is its own little leaf. As you move up the chart, branches start to merge. And here's the secret to reading it. The height of that vertical line where 2 branches meet tells you exactly how dissimilar those 2 groups are. A short little line means you're merging 2 very similar things. A really tall one, like some you see here, means you're mashing together 2 very, very different clusters. Okay, so PCA and clustering are incredibly powerful tools. But, and this is a big but, using them the right way takes a little care. This next section is absolutely crucial because we're going to cover the pro tips that will help you avoid the most common classic mistakes. First, and I really can't say this enough, you always have to scale your variables first. If you don't, a variable with big numbers like income is going to completely overpower a variable with small numbers like age just because the scale is different.
Second, with k-means, don't just guess what k should be. Use a technique like the elbow plot to make a smart, data-driven choice. Third, remember the dendrogram rule. Height means dissimilarity. That's the key. And finally, a little humility goes a long way. There is almost never a single right answer in unsupervised learning. The goal is to find interesting, useful patterns.
And just like that, you've got the foundational tools for both supervised and unsupervised learning. I mean, this is a huge milestone. So let's take a second to talk about what we've accomplished and, more importantly, where you can go from here. If you've been with us since the beginning, you have now made it through all the key ideas from an introduction to statistical learning across this entire 10-part series. That is a massive achievement. So seriously, congratulations. I mean, just think about the ground we've covered together. We started with the humble basics of linear and logistic regression. We moved on to resampling, model selection, trees, support vector machines, and now finally, PCA and clustering. You have built a genuinely solid foundation.
So what's next? Well, theory is great, but practice is everything. Head over to a site like Kaggle and get your hands dirty with some real, messy datasets. If you're ready to go even deeper, the authors wrote a more advanced book called The Elements of Statistical Learning that's basically the next level. Find an online community to learn with other people. And hey, if Python's more your thing, the second edition of this very book now has Python Labs. Of course, none of this would be possible without the incredible work of the authors of this book. So we have to give a huge thank you to Gareth James, Daniela Witten, Trevor Hastie, and Robert Tibshirani for creating such a masterpiece, a text that has launched countless careers in data science.
So we'll leave you with this one last thought. You've put in the time, you've done the work. You now have the toolkit and a rock-solid foundation. The only question left is, what are you going to build with it? Thanks so much for joining us on this journey.